So first what we discussed is this one, differentiability. First one what we discussed, that first principle. Okay,
yes,
so we know that first principle, this is first principles by which you can find out f dash of c. Okay, differentiation of f of x at c. So that limit is to 0, f of x plus h minus f of x by h in the place of x c is there. Okay, this is derivative at a point c. This one we know. And yeah, so if at all, yes, this is what we are discussing. F dash of x is, this is first principle. Limit h to 0, f of x plus h minus f of x by h. So this you can write d by dx, derivative d by dx. Okay, derivative with respect to x of f of x at c. At c. So this is what you learned, and then you have this one, differentiation of u plus v is differentiation of u plus differentiation of v, and you also have this product rule or Leibniz rule. This is called uv whole dash, u dash v plus uv dash, or u by v whole dash. Quotient rule also you have u dash v minus u v dash by v square. And you have, last time I gave this formula, right? F of x is x to the power of n, then differentiation is nx power n minus 1 sin x cos x is minus sin x tan x is secant square x. Similarly, we have other cot x is minus cosecant square x and all. So now what is now differentiability? Differentiability. So a simple thing I told you that if you are able to differentiate a function, then it is differentiable. Okay, yeah, now x to the power of n is there. That's what we discussed last time. X to the power of n is here. Its differentiation is nx to the power of n minus 1. X to the power of n comes under polynomial. This comes under polynomial. So now these polynomial functions, all the polynomial functions are differentiable functions. Differentiable functions are differentiable for all real numbers. Okay, at all real numbers, it's differentiable. Okay, differentiable functions means what? Differentiable functions means what? They are differentiable in their domain, right?
Yes, sir. Okay.
At every point in the domain. So sin x is differentiable function. Where it is differentiable? All real numbers, because domain is all real numbers. Cos x is differentiable. Where? All real numbers. Tan x is differentiable. Where? In its domain. What is the domain? All real numbers, but not odd multiples of pi by 2. Odd multiples of pi by 2. 2n plus 1 pi by 2 we have to remove, because at pi by 2 it is discontinuous. Or there's there's no pi by 2 is not there in its domain. So pi by 2 you need not check. So they are continuous functions and also differentiable functions. Okay, differentiable functions means automatically they are continuous, no doubt. So therefore the conclusion is that if you are able to find out differentiation at point C, then it is differentiable at C. We are able to find out differentiation means it is differentiable. And also, if you are able to find out differentiation at all the point, each and every point in the interval. For example, from A to B, at every point you are able to find out differentiation. Or every point it is differentiable, then it's called differentiable in this interval. So that's what that is what it is. Or now if you take the domain, okay, if function is differentiable at each and every point of its domain, then it is differentiable function. So that is a simple idea. And also, how do you check? So very simple. One point we made, that this does not exist. So this is the first principle. It doesn't exist. That very clearly implies f is not differentiable at C. Yes or no? That means you are not able to find differentiation. This is differentiation definition. This is differentiation f of n. This f of c plus h minus f of c by h. That is this differentiation at C. You are not able to find differentiation. You are not able to find its limit. That means you are not able to find differentiation. That is not differentiable at C. Okay. So same thing. We wrote, right? So if you write the limit h tends to 0 minus, this is left differentiation. This is right. Okay.
Yes, sir.
Left hand differentiation, right hand differentiation. That's what we discussed. Left hand, like left hand limit and right hand limit. We have left hand differentiation and right hand limit. So that also we saw. And here you have a function is said to be differentiable in an interval, closed interval a to b, right? If it is differentiable at every point of closed interval a to b, right? Same as in the case of continuity. That's okay. That I think that is clear, right?
Yes.
Yeah. Open interval also, if it is differentiable at every point of open interval.
So like if
Yeah,
when
correct.
the function is continuous and
Yeah.
the domain is open interval, we say it's left hand continuous, right hand continuous. No, for
Yes,
domain
yes.
A and
Yeah,
B.
whereas so
Similarly over here
here,
also.
no, wait a minute. So good question. Now you see here, this is A and this is B. So now let's say the curve is like this. Now including, see, now I'm writing like this is including. Now at A, it need not be differentiable because at A, you can't draw the tangent at end point. So now you see here, number one point, at end points, you can't draw tangent, no tangent. Yes, sir. For a smooth curve, here you can draw the tangent, here you can draw the tangent, but at end point, at B, you can't draw the tangent. See, in case of continuity, at the end points A and B, we take right hand limit and left hand limit, okay? Which are nothing but left hand derivative and right hand derivative of the function at A and B respectively. So here, that means what? What does it mean? We can't draw the tangent. That means what? Here also same thing, left hand differentiation doesn't exist. You have to look for right hand differentiation here, left hand differentiation. Same thing.
Yes.
You understand?
Yes.
Yeah. See, no tangent at, see here, this is one number one, no tangent at end points. Okay, at end points, no tangent. That means you can't draw tangent, means at A it is not differentiable. At B it is not differentiable, but at A it is right differentiable, at B it is left differentiable.
Left differentiable.
Yes. Second point is at corner points or at vertices of the graph. That graph may be anything, but at vertices are these corner points. At corner points. Okay. No tangent here also, no tangent. No tangent at corner points. For example, we saw the other day, this is the graph of modulus function. Mod x graph is almost like this. And this at vertex, you can't draw the tangent. So therefore, whenever you get vertex, at vertex, you can't draw the tangent. Therefore, slope of the tangent doesn't exist at corner points. Therefore, what do we say? Not differentiable. At corner points. Yes, no tangent means what? Not differentiable. These two things you should remember.
Yes, sir.
One is end points. Okay, you can't draw the tangent. Another is vertex. At vertex, you can't draw the tangent. All right. So, yeah, so we discussed this one. So we also see every differentiable function is continuous. Every differentiable function is continuous, right? So yes. Mod x, he gave the example of mod x. I told you about mod x, which is very, very important. Because mod x is the only function. Mod x is the only function which is continuous but not differentiable. You understand? Continuous but not differentiable. Okay, we discussed about two things. Number one, we discussed is mod x is continuous but not differentiable. Not differentiable. Function. When we discuss about the function, we are discussing in its domain. So therefore, continuous for all real numbers, but not differentiable at x equal to 0. At x equal to 0, it's not differentiable. See here. Yes. At x equal to the corner point, not differentiable. At x equal to 0, it's not differentiable, but otherwise it is differentiable. It's differentiable at 1, 2, 3. So that means it's differentiable from minus infinity to 0. It's differentiable. Union 0 to infinity, it's differentiable. That means what? All real numbers, but not 0. Okay, it's differentiable. So therefore, mod x is continuous function, but not differentiable function. That means what? If 0, it is not differentiable. So this is one. Another thing also you should remember, greatest in integer function, that is integral part function. You can say this is always an integer. And here we saw this is not continuous function. Not continuous, sir. Not
Yes, sir.
continuous. At what points? Not continuous. Not continuous function. But that means what?
Integral point.
At integral points at 1, 2, 3. Therefore, it's not continuous. That means what? The graph is going to break like this. Break. So at 1 it is breaking. At 1 it is not continuous. Therefore, you can't draw the tangent here. So slope of the tangent doesn't exist. Or that means slope of the tangent is nothing but the derivative is nothing but slope of the tangent. Slope of tangent. Yes or no?
Yes.
F dash of x is nothing but slope of the tangent. So when tangent doesn't exist, slope of the tangent also doesn't exist. That means not differentiable. Okay, so not continuous at integral points, therefore not differentiable at integral points. Okay, the non-integral points, non-integers, at 1.1, it's differentiable also, continuous also. Got the point? At non-integral points, it's differentiable also. Okay, derivative of, yes, derivative of composite functions. So we see today this one we see.
Okay.
We'll see different. You understand no composite function?
Yes, sir.
Yeah. Yeah. So today we are going to discuss differentiation of composite function. Chain rule. This only comes chain rule. You learned last year anything about chain rule?
Yes, I think. Yes, sir. I think so. I don't completely remember.
Yeah. So, okay, I'm going to just. Yeah. Composite function is what like this f circle g of x, which is f of g of x. That's what we discussed. This is yeah. Generally, so f is a function from a to b and g is a function from b to c. Then there exists a function from a to c, which is g circle f of x, which is g of f of x. Okay, that's what we discussed, right?
Yes, yes, sir.
So, and f circle g of x is different. F circle g of x is f of g of x. G circle f of x is g of f of x, whatever. So this is composite function or combination of two functions. So here now, how do we differentiate? D by dx of whatever you want to take, g of f of x or g of f of x. So I'm telling first formula. First, what will you do is you differentiate the outside function, that is g dash of f of x into d by dx of f of x. Okay, d by dx of g of f of x is first you do g dash of x. First you do g dash of x. First you do g dash of x. And inside function again you do d by dx of f of x.
Okay. So first we find derivative of g of x.
Yes. So for example, For example, now here you have this. For example, we have, let's say, you have, first, okay, let's take 2x plus 3 whole power 5. So here, if you compare it with the g of f of x, inside thing is f of x. What is inside, you know? What is inside now?
2x
G
plus
of, yeah, 2x plus 3, like this. This is 2x plus 3 whole power 5. Huh? So that means what you can write is f of x is 2x plus 3. This you should be able to recognize.
Yes, sir.
Right? And this is 2x plus 3. So the now here g of x, in the place of 2x plus 3, I am replacing x. G of x is x power 5.
X power 5.
Yes. This you need to recognize first. So now what will you do is, now its derivative, that is g of f of x derivative. So I told you, g dash of x first, g dash of f of x. So into f dash of x. This is what is chain rule. That means what, again, in the place of x, f of x is there, you have to differentiate for f of x, that is f dash of x. So now what is g? What is derivative of this one? You should know this. What is derivative of g of x? G dash
5 into x to the power 4.
5x power 4. Okay, so here also g dash f of x, in the place of x you have f of x. So that is what, you know, 5 into here f of x to the power of f of x 2x plus 3 whole to the power of 4 into d by dx of 2x plus 3, because in the place of x f of x is there. That further also you have to differentiate again. So 5 into 2x plus 3 whole to the power of 4 into differentiation of 2x plus 3. 2 into differentiation of 2x is 2 into x is 1 plus 3 is 0.
Yes.
Okay. 2 into 2 constant you have to keep aside, extra differentiation 1 plus 3, differentiation of 3 is 0, like this. So 5 to the 10 into 2x plus 3 whole to the power of 4. Okay.
Yes,
yeah, this is what is. So now we'll do directly. So we'll take example 2. We'll do directly. d by dx of this is, we'll take sine of 3x plus 5. Like this, we'll take one question. Sine. So this inside function is f of x. Outside sine x is g of x. So we'll do it directly. Sine x ka differentiation cos x, but in the place of x we have 3x plus 5. So into d by dx of 3x plus 5. Is it clear?
Yes, sir.
Okay. So this is cos of 3x plus 5 into d by dx of 3x plus 5 is 3 into
0. I mean 3 plus 0. 3 into 1 plus 0.
3 into cos 3x plus 5. Okay.
Yes.
d by dx of will take some tan 5x square minus 3. So tan x ka differentiation, d by dx of tan x. Tan x differentiation is secant square x.
Secant square.
Yes, secant square x. So therefore tan x, in the place of x, f of x is there. For that we do again secant square x, but in the place of x 5x square minus 3 into, in the place of x what is there? F of x is there. Further differentiation is d by dx of 5x square minus 3. You are getting this one?
Yes, sir.
Okay. So this is secant square 5x square minus 3 into d by dx of 5x square is 5 into x square ka 2x minus 3 ka 0. So that is 10x. You should always write front first. Okay. 10x into the secant square of 5x square minus 3. Okay, like this.
Yes, sir.
So did you learn this d by dx of tan cot x? What is the differentiation of cot x?
Cot x is
minus cosecant square x, right? Cosecant. Yes, yes. Cosecant square x. So
Yes, sir.
The other day I told you to learn. I wrote
Yes,
also.
sir.
Last class I wrote, so you should learn. Divide
Yes,
x of
sir.
secant x is secant x into tan x. And divide x of cosecant x is minus cosecant x cot x. You should learn this. Then only you can do.
Yes, sir.
Okay. So now based on this, you have an exercise. So yes. So this is what is chain rule. Okay. This is what is chain rule. And here d by dx of sine x square. Now I discussed d by dx of sine x square. So that sine x square we did. And you can just do the examples tan of 2x plus 3, which we discussed. So now one more question is there. Here you have sine of cos of x square. So we did with only two combination of two functions, but you have a combination of three functions. So like that. So here also you have so many. So but here I would like you to complete this exercise. 5 point today your exercise is 5.2. You need to do this one 5.2.
Okay, sir.
And I'm going to tell you few more examples. I'm going to tell you, but you can do the exercise yourself.
Okay, sir.
Yes. Okay. So next, d by dx of cos x cube into cos x cube into secant 2x plus 3 whole square whole power 5. Yes. You understand? ये वाला तो u हो गया. This becomes v and we need to apply u into v. Okay, because
Yes.
here two functions are there. Inside function is the other thing. But you have first of all this uv. So uv all dash is u dash v plus uv dash. Okay. So now cos x cube is equal to cos x cube whole dash. I am writing like this into secant 2x plus 3 whole power 5 as it is. U dash v हो गया. Plus this becomes u cos x cube secant 2x plus 3 whole dash. U dash plus u v dash. So this becomes derivative of cos x cube now. Tell me the derivative of cos x cube.
Derivative of cos is so derivative of cos is minus sin x into 2 3 into x to the power 2 and secant 2 into 2.
That is same. Yeah, its derivative is
that will come
by
down.
by using chain rule minus sign in the place of x cube is there. Okay, minus sign x cube into derivative of in the place of x what is there you need to check. In the place of x you have in the place of x cube is there, you have to differentiate x cube again like this you have to write. And this is same thing, secant of 2x plus 3 whole power 5 is same plus cos x cube is same. And for the differentiation divide x of secant
x into tan x into
so secant x means 2x plus 3 whole power 5. See, understand. In the place of x, this is there, that only. That is f of x. That's g of f of x you should write. G dash of f of x.
Yes, sir.
So this is secant x tan of 2x plus 3 whole power 5. So this is differentiation into d by dx of in the place of x 2x plus 3 whole power 5.
So that is 4 into 2x plus 3. 5 into 2x plus 3 whole power 4.
Yes. So again, we have to do this is minus sin x cube into derivative of x cube is 3x square into secant of 2x plus 3 whole power 5 plus cos x cube u v dash is secant 2x plus 3 whole power 5 tan 2x plus 3 whole power 5 into divide x of 2x plus 3 whole power 5 is 5 into
5 into
2x plus
2x
3
plus 3
whole
whole power
power 4.
4.
Okay.
Yes, sir.
Not only that. See, here again, in the place of x, 2x plus 3 is there. No, 5 into x plus 3 whole power 4 into d by dx of 2x plus 3 again.
Oh, okay.
That is 2.
2.
You understand? It's derivative again.
Yes. Okay. So because that is f of x, right?
Yes, this is inside thing is f of x, outside thing is g of x. So like that. So this thing you should notice.
Yes, sir.
So we'll take one more example. I'll write the next example. First, I will say this one. Okay, let's take d by dx. We are taking picture or what are we doing here?
I took pictures of that.
d by dx of root x. So you need to remember this one. D by dx of root x. You know what? D by dx. What you can write root x? What you can
root
write?
x.
No.
Root x is x to the power minus 1 by 2.
Oh, what is that minus 1 by 2? X to the power of minus 1 by 2 is what? No, what is no. Root x is what I'm asking. Root x is simply d by dx of root x is x to the power of 1 by 2, hai na? Yeah, this is, yeah, you do it now. X to the power of n is n into x to the power of n by 2, n minus 1. N into x to the power of n minus 1. You apply the formula, so 1 by,
Yes, right.
yeah.
I thought I was wrong. That's why I got.
Why you should think right? No, you should check. You know the formula and also you need to check. You should not get confused. So here 1 by 2 root x. So what you should remember is root x ka derivative 1 by 2 root x. This you need to remember. All the time you can't do it. No? But see, it's, remembering is not so difficult because 1 by 2, see, just by saying x to the power of 1 by 2, x to the power of 1 by 2 is 1 by 2 into x to the power of 1 by 2 minus 1. That is 1 by 2 into x to the power of minus 1 by 2. 1 by 2 into x to the power of minus 1 by 2. So that is all 1 by, yes sir, this is 1 by 2 root x. 1 by root x, this is. If it comes to the denominator 1 by x to the power of 1 by 2. 1 by 2 root x. So you can remember it. Okay?
Yes, sir.
You can remember also. Okay, so now next one is root of tan of the root of 3x plus 4. Its derivative I want, and let's say. Okay.
Okay.
Root of tan x. Root x, no, first you should know root x derivative, that is 1 by 2 root x. Now, here inside function, whatever is there, that is x for us. Yeah, this is f of x. Now, f of x is inside function, that is tan of whatever, root of 3x plus 4, whatever it is. That is what is, so we don't worry about that. Outside function is root of f of x. Now, root of f of x is 1 by 2 root f of x into f of x by f dash of x, like this. So we don't worry about, first we don't worry about f of x. So we worry about this one. That is 1 by 2 root of tan of root 3x plus 4. Okay. You understand? 1 by 2 root f of x into f dash of x, we should not forget. What is f dash of x? D by dx of tan of root 3x plus 4. Okay?
Yes.
Right? 1 by this is 2 root of tan of root 3 plus 4. This is same thing. Again, so again, what is next? What is next here? This is f of x again. Okay. Now tan x ka differentiation, you know, d by dx of tan x is, now what is secant square x? Now in the place of
Yes,
x,
sir.
you have to write f of x. So that is secant square root 3 plus 4 into, in the place of x, what is there? F of x. Now for that again differentiation. This is chain rule, understand? Here 3 functions are there, not 2
Yes.
functions. So root of tan of root of again. So you see 1 by 2 root of this thing is same, tan of root 3a plus 4. This is same thing. And the next you have secant square 3x plus 4. Again see 1 by 2. See for this, see 1 by root x, 1 by 2 root 3x plus 4 again into 3x plus 4 ka 3. Take a picture, it's going to go in a half minute.